Hey guys, welcome back for another chemistry lesson. In this video, we're going to talk about how to name simple compounds when given their formula. So I have a little flow chart here for you about how to go about naming. And it's intended, if you use this flow chart, to guide you in answering questions that help you figure out what kind of compound it is. And then there are rules for naming that kind of compound, right? So the first thing you're going to look at is how many elements are present. If there are two types of elements, then we're worried about, do we have all nonmetals or a combination of metals and nonmetals? If there are more than two elements, for the purposes of general chemistry, it doesn't matter. We're going to treat it as a ternary ionic compound because there's a polyatomic ion in there. So let's practice some of this naming. All right, this first one, C4H8, and I'm actually going to leave it up here. All right, C4H8. First thing is, how many elements are present? Here, I've got C and H. That's two elements. So now, what types of elements are they? Well, carbon and hydrogen are both nonmetals. So I'm going to follow the naming rules for molecular compound. So if our first element has a subscript, we're going to use the appropriate number prefix. And I'm going to write those out for you right now so that you have those. One is mono, and most of these are things that you'll be familiar with already. So we got mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. All right, so here we need the prefix for 4, so tetra. Then we name the nonmetal just as it's written on the periodic table, so tetracarbon. We use our number prefix for our second element, octa, and then instead of naming it as it is on the periodic table, we change the ending to IDE, so octahydride. Now, a question you might ask yourself is, how do I know where to change the ending to IDE? And I call this the stupid rule. Basically, whichever sounds the least stupid as your options, that's going to be the one that you go with, because your options here are hydrogenide, hydrogide, or hydride. In my opinion, the first two sound really dumb. So the third one is what we're going to go with. So just ask yourself that question if you get stuck. But as you name, you'll get more and more comfortable with this. All right. So the next one is CCl4. I've got C and Cl, which means I only have two elements present. Carbon and chlorine are both nonmetals. So we're going to follow that same naming rule for this one. All right. If the element has a subscript, this piece is important. For some reason, the powers that be, whenever naming conventions were created, decided that if you have one nonmetal for your first nonmetal, you don't write a prefix for it. So this is not monocarbon, it's just carbon. Every other number gets a prefix, but for some reason, one does not. However, if you have one of the second one, you do use mono on the second element. All right, so we write it just like it is on the periodic table. Step 2, use our appropriate number prefix. This is 4, so that would be tetra. And then change the ending of our second nonmetal name to IDE, so that instead of chlorine, we have chloride. Carbon tetrachloride. All right. So next thing is NiCl2. All right, we've got Ni and Cl, which means I have two elements present. But Ni, nickel, is a metal. So we are going to come over here and follow the rules for metals and nonmetals. All right, so we are going to, step number 1, write the name of the metal. Nickel. If it is a transition metal, your transition metals are going to be in the middle, and generally speaking, these have options for what their charge could be. So if it's a transition metal, we're going to write its charge in parentheses in Roman numerals. I'm going to come back to that, but I'm just leaving the space for it right now. Then step 3, write the name of the nonmetal and change the ending to IDE. This piece is just like with our molecular compounds, but you should never have a prefix. If you're over there dealing with ionic compounds, never, ever, ever have a prefix. So chlorine becomes chloride. Now, you just have to think about it math-wise to figure out what charge we put up here. So chlorine, we know, has a 1 - charge, and I have 2 chlorines here. So that's a total of 2 - charge that has to be canceled out by our nickel. We know it has to be canceled out because this is a neutral compound. Nowhere on any of these do we see charges indicated. So that means that our charges add up to 0. Right? So if it's 2-, that means my nickel has to be 2+, and that only goes to 1 nickel because I don't have a subscript. So that 1 nickel has to be 2+, which means we give it a Roman numeral 2 in the parentheses. All right, NaNO3 is next. All right, Na, N, and O. That's more than 2 kinds of elements, which means it's a ternary ionic compound. For a ternary ionic compound, we use the same steps as our binary ionic compound, so the stuff we just did, but we're going to insert the name of a polyatomic ion wherever it lands. If it lands where the metal goes, then we put it there. If it lands where the nonmetal goes, we put it there. All right, in this case, it's the second piece of our problem. So Na is sodium. And then NO3, we just have to name our polyatomic ion. NO3 is nitrate. All right, next one, K2O. All right, in this case, I have 2 elements. Potassium is a metal, so I'm going to be doing my binary ionic compounds. Again, K is potassium. It is not a transition metal, so I'm not going to do parentheses. And then O is oxygen. Change the ending to IDE. Okay, next one. I've got Fe and O. There are 2 types of elements, and one of them is a metal. So I'm going to follow my binary ionic compound rules. Step 1, name the metal. That would be iron. Iron is a transition metal, so I'm going to leave that space there for its charge. And then we name our nonmetal, changing the ending to IDE, so oxygen becomes oxide. And now I got to figure out the charge on that iron. We know oxygen has a charge of 2-, but there are 3 oxygens. So that's 6-. We have to exactly cancel that out because, again, as I pointed out previously, no charges on any of these. So they're neutral compounds, right? So that means total, my iron has to be 6+, but this time it's divided between 2 atoms. So each of those is 3+. So iron 3 oxide. All right, the next question, Al2O3. We've got Al and O, so that's two types of elements. Al being aluminum, it is a metal. So same steps we just did. Got Al is aluminum. Aluminum is not a transition metal, so no parentheses needed. And then oxygen becomes oxide. All right, and this last one here, P4S10. We've got P's and S's, that would be two elements. Phosphorus and sulfur are both nonmetals. So now I'm going to be needing my prefixes. All right. If our first element has a subscript, it does. So I need to bring tetra over here, and then we name our nonmetal just like we would on the periodic table. And then the second one, we need a prefix, deca, and then we change the ending to IDE on this one. So sulfur becomes sulfide. Tetraphosphorus decasulfide. Okay, I have one last special circumstance that I want to teach you guys how to name. And that would be if you have a hydrate. This is a weird notation, but it just is what it is. It's going to be some ionic compound, and then you will see this dot here, and then a number of water molecules behind that dot. This means that we are never going to see this barium chloride without two water molecules attached. That's what that means. So if you're calculating your molar mass, do so with the two waters added to it. In this case, we're naming it. So what you do is you name your ionic compound just like you would. So in this case, it's barium chloride. Again, follow those steps. But then after that, you have to tell how many waters, and you're going to use those same number prefixes that we had before. So this is 2 waters, so that would be di, and then you say hydrate. So this is barium chloride dihydrate. Okay, so that is it for going from formula to name on simple compounds. Organic compounds have their own naming rules, but I am going to put in the description below a link to a PDF file of a foldable that I have created that helps you walk yourself through these thought processes, like the questions that you're asking yourself and whatever. So I'm going to link that in the description below. You are welcome to download that. If you are in my class, I will have given you this foldable, but the point is, use the foldable, learn the questions that you need to ask yourself in order to figure out what kind of compound it is, and then name according to these rules.